Hey guys, welcome back to my YouTube channel. In this video, we'll learn one of the ways to automatically increment version code in an Android project. For me, this is a very helpful feature. Let's open the project and show some code. We'll open the build Gradle file of the Android application, and in the file, we'll create an extension function of the project class that will return version code of integer type. Project dot get version code. For the debug build variant, we set a static version code that can be passed as a function parameter. Debug version code, integer type, and default value can be 1. Integer type. Now we need to detect the debug build. We can implement this as follows. Gradle dot start parameter. Start parameter defines the configuration used by a Gradle instance to execute a build. Task names. Return the names of the tasks to execute in this build. If the name contains debug, then return true. If the isDebug build value is true, we return the past static value from the function parameter. We'll add a log so we can see the debug version code in the logs. And return debug version code value. The first part for debug is done. We'll add to do get version code from Git. In the second part of the function, we need to get the commit count from Git. To implement this solution, we'll run git command. It can be implemented using ValueSource. It represents an external source of information used by a Gradle build. Examples of external sources include client environment variables, system properties, configuration files, shell commands, network services, among others. Representing external sources as value sources allows Gradle to transparently manage the configuration cache as values obtained from those sources change. For example, a build may run a different set of tasks depending on whether the CI environment variable is set or not. That's how it's described in the documentation. Let's create an abstract class of ValueSource interface. Abstract class git commit count ValueSource and interface ValueSource with return type integer and parameters can be ValueSource parameters none. will override the obtain function. Let's inject exec operations. We'll need this object to call the git command. We'll create a byte array output stream. And call use function. It executes the given block function on this resource and then closes it down correctly whether an exception is thrown or not. Std out. Now we'll use exec operations and we'll call exec function. We'll add command line. Git ref list add, and the last one is count. And set standard output. We'll return the result, which we store in the commit count value. The value is of string type. Let's convert it to int type. If the value is null, we throw an exception. Commit count dot to int or null dot also we will add a log of version code from Git. And return it. If was commit count now, we will throw illegal state exception. Failed to get a version of the code on this platform. Now we can solve the to-do in the getVersionCode function. Now we'll get the provider, providers dot of git commit count value source class.java. And we'll call get function. We are done here. Let's sync the project. And now we can call the getVersionCode function. Sync the project once again. Let's open the terminal. And we'll also check if the function is working correctly. First, we'll check the debug variant. Run the command. Android app assemble debug. Debug version code is 1. It looks fine. Now let's run the assemble release task. It should return the count of commits. Version code from Git is free. That looks fine too. Now we have learned how to automatically increment the version code with each commit. Each commit represents a unique state of your codebase, ensuring that every build has a distinct version code. Be aware that the commit count will differ across branches. If you are generating release builds from different branches, ensure that this won't cause issues with your versioning strategy. Later in video, we will show how to move code to the buildSrc directory and how we can set up Gitlab to work better with merge requests. Let's do it. Let's create a new feature branch. Feature slash version dash code. Create. Let's commit and push the changes. Automatic incrementing of version code. Commit. Now we'll create a directory named buildSrc on the root of the project. Next, we'll create a build Gradle file. The contents of the file can be copied from the same file in the build logic directory. Similarly, we can copy the settings Gradle file. Source slash main slash Kotlin. And we'll create a common directory where we'll move the code. We sync the project. Oh, sync failed. Why? I see. We can use alias to add plugin dependencies. Let's fix it. We'll use ID instead of alias. Try again. Let's edit one more file. Try again. Nice. Sync passed. We fix it. Now we can move the code to the common directory. We'll create git commit count value source class. And project file. We'll add common import for get version code function. We sync the project. Everything looks fine. Let's commit and push the changes. Move the code to build source directory. Commit and push. And now let's show some GitLab setup options. For Git linear history, we can choose merge commit with semi-linear history. It's a hybrid approach to merging branches that combines aspects of both rebasing and merging. It's often used to maintain a cleaner, more linear history in a Git repository while preserving the contextual integrity of commits. Squashing commits when merging set to require. As you work on feature branch, you often create small, self-contained commits. These small commits will describe the process of building a feature, but can clutter your Git history after the feature is finished. As you finish features, you can combine these commits and ensure a cleaner merge history in your Git repository by using the squash and merge strategy. Pipeline must be succeed, and all threads must be resolved. To see the full depth of Git history, you need to set Git shallow clone to 0. It can also be set specifically for CI/CD jobs for better performance. Save changes. Oh, I didn't save the changes. I'll do it again. Save changes. Now we'll create a merge request with title automatic incrementing of version code. Assign to me and create a merge request. We'll wait for the pipeline to finish. Pipeline passed. Now we can merge. Let's check out to main branch. Now in the logs we can see the version code is 5. Before this feature was merged, the version code should be 3. You can look back in the video. Yeah, it's an amazing Git history. And I'll end the tutorial here. In this video, we learn how to automatically increment the version code in an Android application. We also demonstrated how to set up Gitlab when working with merge requests. We'll use the feature in the next video where we'll show how to upload an application to the Firebase app distribution or Google Play. I will add here a link to the previous tutorial. I hope you enjoyed the video and learned something new. Thanks for watching. And be sure to like, comment and subscribe for more videos like this.